In this lesson, we are going to talk about rate of change. So rate of change is how we see the change in your vertical movement compared to your horizontal movement between 2 points. It is a difference in numbers. So we're going to be talking about using subtraction here, okay? In order to find the rate of change, you have to find the rate of change between 2 points. And so we can talk about the first point being our x1 and y1, and the second point being x2 and y2. You always want to talk about your y values being on top and your x values being in the bottom of the fraction. So sometimes you'll hear this described when we're talking, especially a lot in linear functions, as your rise over your run. So you're up and down over your side to side. Okay. If you've heard of slope before, you probably have seen the slope formula, which looks like this. Your points don't necessarily have to be in order when you do this. It doesn't matter which one you start with. Your rate of change would be the same because you're just talking about the difference between those points. Now, you can use the slope formula, y2 minus y1 over x2 minus x1, but I like to use delta y over delta x. That simply just means the change in y over the change in x. Okay, so this is kind of what I like to do. I like to line up my points vertically and then subtract the x's, subtract the y's, and just make sure I put the y's on top. Okay, now as we go through this lesson, a couple important things to remember: that f of x and y mean the exact same thing. You are going to see them used interchangeably all year long. So it's important that you know if you see f of x, it means the same thing as y. Also, you're going to start seeing bracket notation or bracket notation and interval notation. Today, when we're talking about rate of change, this is bracket notation. This is not an ordered pair. It's very different from when you see an ordered pair. All this is letting you know is this is the first and the last number in your function. So these are both x values or input values. Okay? So very important to notice the difference. And really the biggest thing you need to know about bracket notation, interval notation, all of that is look at the context around it. Okay? If we're talking about a point, you'll see parentheses, that's a point. If we're talking about an interval, you will see brackets usually, unless the interval doesn't include the point. We'll talk more about that in domain and range, but it's very important that you know that this is not an ordered pair. So let's dive right in. We have here what is the average rate of change from f of negative 3 to f of negative 5. Now, if you think back to when we were evaluating functions, that's what we have to do first. Our first step is to evaluate each value. Are these values here input values or output values? They're input values. Remember, f of x, so they're telling us that x is going to equal negative 3 and x is going to equal negative 5. So I'm going to go over here and make a table with my x and then my f of x values. I'm going to start with my first input value of negative 3. All right. And I'm also going to put in there my my x value of negative 5 because I'm trying to find f of negative 3 and f of negative 5. Now I've got to go evaluate those. So let's start by finding f of negative 3 using this function. So I'm going to say negative 3 squared plus 4 times negative 3 minus 7. And this is a lot of calculator work. So we get 9, and that's a positive 9, plus a negative 12, and minus 7. So that's a negative 3 minus 7. So I have that f of negative 3 is negative 10. So I'm going to go put that in my table next to my negative 3. Okay. Then I'm going to do the same thing for f of negative 5. And I'm going to use the same function, x squared plus 4x minus 7, but I'm plugging in that negative 5, right? So 5 squared is 25 plus a negative 20 and minus 7. So this is going to become positive 5 minus 7. So f of negative 5, I got a negative 2. I'm going to put that in my table. Okay, with me so far? Let's move all of this out of the way. So I'm going to put all of that over there. That's how I evaluated and got the points in my table. So now we are going to subtract the y values and put it in top of a fraction. So I'm going to say, going down this way, remember f of x is the same as y. So I'm going to say negative 10 minus, we're subtracting, my value is a negative 2, over. I'm going to subtract the x values and put it in the bottom of the fraction. So I'm going to go this way. Negative 3, we're subtracting, and it's a negative 5. And then I'm going to actually do that subtraction. So I like to do the stay, change, which means negative 10 stays, these two change. So negative 10 plus a positive 2 will give me a negative 8. And on the bottom, I have another stay, change. So negative 3 plus a positive 5 will give me a positive 2. And then I can reduce the fraction. I get a negative 4. So my rate of change is negative 4. All right, so we evaluated the function, put them in a table. I subtracted the y values, subtracted the x values, and then I reduced the fraction. Perfect. Let's look at number 2. This time they're giving us a table, and we have an interval of 3, 5. Remember that in an interval, these are input values. Okay? So when I go, I'm going to make myself a second little table over here, where I'm going to say x and f of x. Okay? Now, we do have 2 different problems to do, so save yourself some space. I've got to write a little bigger, but you save yourself some space so you can fit in 2 problems. Okay? So first, my 2 input values are going to be 3 and 5, because this is the first value, this is the second value, so it's our first and our last value in our interval. So then I've got to evaluate it. So when I'm looking at the table, I'm going to look for 3, and I found the point 3, 8, so I'm going to put the 8 into the table. Then I've got to look for 5, so I have 5 and 32. So think back to our steps. I've got the points in the table, so I'm going to subtract my y values, and then I'm going to subtract my x values on the bottom. So start with my y values, which is the same as f of x. So I'm going to say 8 subtract 32 over 3 subtract 5. And then we simplify. So 8 minus 32 is going to give me a negative 24 over 3 minus 5 is a negative 2. Reduce that and we get positive 12. Okay, so for part A, our answer was 12. Now let's talk about part B. Okay, what is the average rate of change from f of 1 to f of 4? So this 1 and this 4, are these input or output values? These are input values. Remember, this is what x equals. Okay, so I'm going to make myself a new table with x and f of x. And we're going to put those values in. I've got 1 and 4. So now we've got to go evaluate those. So remember, we're looking at the input values for 1 and 4. So here's my first one. Here's 1. So I'm going to put a 2. What am I going to put in the f of x column for 4? Well, here's 4, so the output value is 16. So, again, remember your steps. Subtract the y values, then subtract the x values. So I'm going to start with my y values. Y is the same as what? As f of x. So what are the two values I'm going to subtract? 2 minus 16, and I'm going to put that over what? 1 minus 4. When I do this, 2 minus 16 is a negative 14, and 1 minus 4 is a negative 3. When I reduce that, it just reduces to a positive 14 over 3. You could also make that a fraction. I'm sorry, it is a fraction. You can make it a decimal. So that would be 4. I'm going to round to the nearest hundredth, so 4.67. So either one of those would be acceptable. Well, let's try the next one. This one is in context. What is the average rate of change from year 2 to year 6? And this is really important. Make sure you include units in your answer. Anytime that you have a context question, make sure you include units. Okay? So let's think about this year 2 to year 6. Would those be input or output values? Those are input values. Usually when you're asked to find the rate of change, they're going to give you the input values. Also, in your table, this is x, this is y. The amount of money is dependent on the time in years, therefore time in years is your input and the amount of money is the output. It's kind of like independent and dependent variables, right? So our input values that we're talking about are 2 and 6. So I have my x and my f of x. So what would be the output value for an input of 2? Well, 2 and 130. What would be the output value for 6? 380. So then again, our next step is to do what? To subtract my output values. So I'm going to say 130 minus 380. And I'm going to put that over what? 2 minus 6. That's my x values, right? So then we go through and we do our math. 130 minus 380. 250, negative 250. Over 2 minus 6 would be negative 4. And I know that a negative divided by a negative will make a positive. Looks like 62.5. And we are talking about amount of money, right? So $62.50 per year. Oops, sorry guys, my pen's not working. And I know that it's $62.50. I had to add that 50 cents because we're talking about money per year, because if we were to reduce this, it would come down to 125 over 2, and it's $125 over 2 years. So if I make that my decimal, that's 62.5 over 1, so $62.50 per year. Okay. The last one we have here is for a graph. So we've got to evaluate from a graph, just like we did in lesson 2.1b, I want to say, or lesson 3, depending on if you're online or in class. So we've got to start by figuring out what are our input values. So if we're looking at part A, what are my input values? Great, remember that's an interval. It's not an ordered pair. Okay? Also keep in mind we've got two problems here to do again. So make sure you give yourself some space. So my input values here are -7 and -5. Let's go evaluate those in the graph. What do you get as an output for an input of -7? Well, you've got to count over 7 spaces to the negative direction. 1, 2, 3, 4, 5, 6, 7. And I'm going to look up. That's the point I'm looking for. That point is up 1, 2 spaces, so that's a +2. For the second one, I'm going 5 spaces. So what do you get for an output for an input of -5? 1, 2, 3, 4, 5. I'm going to go down. There's my graph. So that's 1, 2, 3, 4. That's a -4. What's my next step? We're going to subtract our outputs and put them over our inputs. So I'm going to say 2 minus -4 over what? -7 minus -5. Do a little state change here. I get a 6 over, another state change, -2. So for this first one, I get a rate of change of 3. Let's look at the second one. These values here, -3 and -1, are they input or output values? They are input values. So I'm going to put them under the X column in my table. What do you get for an output with an input of -3? We're going to go over 3 spaces in the negative direction. 1, 2, 3. I go down. My output there is down 1, 2, 3, 4. So that's a -4. What do you get for an output for an input of -1? We are going over 1, and it's up, looks like 2. Also, guys, I just realized I forgot the negative on this one. It's a -3. Sorry about that. So we went up 2, so we've got our table. What's our next step? It's to subtract our output values, put them over our input values. So I'm going to say -4 minus 2 over -3 minus -1. What's my answer? I get a -6 over, state change, a -2, and negative over negative makes a positive. So it's kind of interesting to me. On this side of the function, I had a negative, and on this side of the function, I had a positive. Does that look like it might make sense? This one's going down, so it's negative. This one's going up, so it's positive. Cool. I think that's it. So go ahead and start your practice.